Okay. So what I want to do is I want to put this function in on the calculator. Does anybody need more time? Stop me if you want me to wait just another second if you're in the middle of it. Okay, so I'm going to show you how to do it on the TI-84 or the 84 or the Calc 84. So what I want to do is I'm going to put this function in, yeah, and I'm going to go over one again, Sean. Yep, so I'll show you this now on the calculator. So I'm going to enter in this function into the y equals. Okay, so what you're going to do is you're going to go into your y equals, and sorry, I can't like keep both screens up, but the function was x cubed. And if you're like me, I already forgot. Let me write it down really quick. So it's x cubed plus x squared minus 10x plus 8. So that function I have in y1, I have x cubed, arrow down out of the exponent, and then plus x squared minus 10x, and then plus 8. Okay. We could type it in our calculator the way we wrote it out with all of those parentheses, but that takes a long time, and then we'd have to do it again for the second number. So this is helpful when you're evaluating the same function at different values. Okay, so I've got the function entered in that I'm investigating and trying to find the zeros as y1. So on here, we found the 0. So the rule is we find the 0 because we're trying to find the 0 of this. And then we want to plug that -2 into the function. The calculator can do all of this for us without us having to type in those parentheses. So what I can do is I can pull up y1. So what you're going to do is you're going to hit second quit to go to your main screen. So again, all I've done so far, and it's important that you guys stop me if I lose you on a step, but in y equals, I've entered in this function, which is just x cubed plus x squared minus 10x plus 8. Then I hit the blue button, and the button right next to it says mode, but above it in blue, it says quit. So that's where I hit the second button and mode, and it takes me back to like the home screen. If you have anything entered in on here, just hit clear, so we'll be on the home screen. Okay, so we can ask the calculator to pull up that y1 function so we don't have to type it in again. Y1 is, if you look at your top row, you have this trace button. You see trace, it's right next to graph. Above it, in blue, it says calc, and in green, it says F4. We want to go to that F4. Since it's in green, you hit your alpha button and then trace, and then it will pull this up. Look how fantastic it is. It has y1 highlighted for us. So if you hit enter on y1, that's the function. So it's going to evaluate it for us. We wanted to evaluate this function at -2. So all we have to do is put a parenthesis around -2. Right above 8, there's a parenthesis. So right above 8, there was a parenthesis, and it's pulled up parentheses. You just type in the number you want evaluated. We wanted to plug in -2, and you can close the parenthesis. This notation on our calculator, when it says y1 at -2, that's exactly equivalent to f at -2. We hit enter, and there's the 24. So we didn't have to type in all the parentheses and everything. Yes, I will. Thank you, Sean. Okay, so I'm going to connect it back to what we did here. So by hand, I'm going to go ahead and erase this, because most of the time, to be honest, I'm lazy and I don't like doing all that arithmetic by hand. So if I'm trying to figure out what the function is evaluated at a number, I enter this function in y1. So I put that function in as y1. So on my calculator, I bring up y1, which to get y1, you hit your green button. I don't remember what it says, but you do your green button and trace. And that will give you the option to bring up y1. And then you put in parentheses, you put a -2, because this is the exact same thing as this. Our calculator is just calling f y1. You hit enter, and our calculator told us it was 24. When we did it by hand, we got that it was 24. It just took us longer. So I know this first time through, you're like, well, this isn't really saving us time. This takes us forever, but I promise it will go faster after we're used to it. So I'm going to show you those steps one more time on the calculator. So again, what you do is you first go into y1, you enter in your function. So I just have the function entered in there as y1, x cubed plus x squared minus 10x plus 8. Then you have to hit second quit to go back to your main screen because you don't want to do anything in this screen. So you hit your blue button and then mode right next to it. I'm going to hit clear, but I need to bring up that Y1. So again, it's the green button or alpha, in case it's different on yours, and then the trace button. So Sean, are you using the Wabbit EMU, the one on the Android?
No, I'm actually using the real calculator.
Okay, perfect. Who's using the one on the Android? I'm curious if it is the same process, if anybody's running into any difficulties. Don't be shy, please speak up. Okay, then I'm going to go on. But it would be fantastic if you let me know. Okay, so we have Y1, then you have to do a parenthesis. So you do a parenthesis, which is right above the 8, and you just type in the number that you want plugged in, and we hit enter. Oh, syntax there, what did I do? Oh, I don't know, let me try that again. Y1 evaluated at -2. Of course, what am I doing wrong? Syntax there. After that 8, I have a minus. I don't want a minus right there. Okay, so I need to try that again. I just had the function entered in incorrectly. There we go. Okay, I'm going to show that to you several more times. So the connection to this, why we care about this, if this number is not 0, then x plus 2 is not a factor. Okay, so I'm going to use that shortcut from now on. So I'm going to go to the second one. So let's practice this again. Same function. What is the 0 of x minus 1? What x value makes that be 0? X equals what? I'm going to pick on Keaton. What do you think? I think you answered me last time too. What x value makes x minus 1 equal 0?
X minus 1.
So it is x minus 1.
Just add 1?
Exactly. Good. So we're just going to fine. Exactly. So to make it be 0, we just change it so x equals 1. So now we want to evaluate the function, and we put a 1 in the parentheses. We want to know if we get a 0 out. So I'm going to go to the calculator, and this is where it's helpful. We already have this in Y1. So we just go back to our calculator. In Y1, we have the same equation. We're not changing it. So I go to the main screen. I pull up Y1 by hitting alpha and trace. So there's Y1. And this time we're plugging in a positive 1. I want to know if this gives us a 0 or not a 0. And this time we get a 0. So when we plug 1 into that function, we get 0. I'm going to come back here. So we got 0. If you don't like using your calculator, what we basically did is we plugged 1 in. So we did 1 cubed plus 1 squared minus 10 times 1 plus 8. And that equals 0. So if you'd rather do it by hand, you can, but you're going to have to do a lot of these, so it would be nice to use your calculator. If it's 0, that means x minus 1 is a factor. Okay, now you only have 4 of these problems today because they do take a while. Once you've found a factor, now we use synthetic division to write the polynomial in factored form. So if you know it's a factor, we know we're going to get a remainder of 0. So if we're following synthetic division, which is what you did yesterday, you take your 0, which was the 1, and we put 1 in the box. And then we list the coefficients. So I'm listing the coefficients in front of each of these terms. We don't have to include any zeros because the powers went 3, 2, 1. So when I list, I've got 1 from the x cubed, 1 from the x squared, a minus 10, and then an 8. Quick reminder, if it's a degree 3, you should have 4 terms. You always have one more term than the degree. So degree 3, I have 4 terms listed. And now we do our synthetic division. We drop the 1. Okay, I'm going to pick on Natalie. Are you okay helping me through this synthetic division question?
I'm not really good, but I can try.
Okay, thank you. I appreciate that you're going to try. So what is 1 times 1? What do we get from that?
1.
Perfect. And so that answer goes right below there. So we get a 1. and now we add. So if we add those two together, what do we get down here?
2.
Perfect. And then we just repeat this process. So we're going to do the number in the box multiplies the number underneath the line, and we write the answer right there. So 1 times 2 gives us what?
2.
Perfect. And then we're going to add these two together. So what's a negative 10 plus 2? Does anybody remember the rule that we talked about yesterday, that if they're different signs, you can just do like 10 minus 2. So how far apart are 10 and 2? What's the difference between those two numbers?
8.
Good. And since the bigger number is negative, it stays negative. And then we repeat this process. So now we do that again. So what's the 1 times negative 8? That would give us a negative 8. And notice when we add these together, we get a 0. And we should get a 0. Like this is a 0. That's our remainder. But we knew we would get a 0 because of what we did over here. So I was expecting a 0 because it was a factor. It did work. Gave us 0, and that should be our remainder. So now what we have is when we write this in factored form, I take this 1. We already know the factor that came from. That came from x minus 1. So I write x minus 1. That's that factor. These 3 terms, we drop by a power because it was a degree 3. If we drop it by a power, this is x squared, and then a 2x, and then a minus 8. So the only thing we're doing different on this is we're writing them actually as a product. We're taking the factor, the 0, and we write it back as the factor. So the 0 of 1, we go back to the x minus 1. These 3 terms give us our quadratic. X times x is still x cubed, so this is equal to f of x. Our goal is to write f of x in factored form. Now we get to practice factoring. We want to try to factor this quadratic. So that quadratic, it's 3 terms. So I'm going to try, you can do the guess and check, or you can do your diamond. So I would ask myself, I'm going to do guess and check. I'm going to ask myself, what times what multiplies to x squared? Carson, I'm going to come to you. Can you help me factor this? What times what multiplies to x squared?
2x plus x.
Okay, so first just think about, since there's a 1 in front, it really is just going to be like 1 and 1. And to get x squared, it's going to be x and x. It's been a while since we've factored, I know. Does that make sense?
Okay. No, I know what I did wrong.
Okay. I'm going to go ahead and ignore the 2x for right now. And now I look to the last term, ignoring the sign. I have an 8. What are 2 numbers that multiply to give me 8?
2 times 4.
Great. So I could try a 2 and a 4. And if you guys remember, again, I know it's been a little while, you check your outer product and you check your inner product. We're trying to get the middle term. I'm trying to get a positive 2x. So if I did a positive 4 and a minus 2, it would work. So I put a plus with the 4 and a minus with the 2. Or you could have done the diamond method. So however you want to factor, but we take this quadratic and we factor it. The x minus 1 just stays in front. Now we have it in factored form. Kind of another heads up, another thing to check. This original was a degree 3, so I expected 3 factors, 1, 2, 3. So I have it into 3 separate factors. So now I'm done. I've got that quadratic written in factored form. Okay, so again, I know these ones take a while, so you only have to do 4 of these today. You have 4 of these questions today. You ready to see one other example? Yeah, Sean.
Miss Brown, how come you didn't use the box method?
It's choice. It's whatever you want. If you did the box method, did you do the box method, Sean?
I didn't, but I was curious why you didn't.
I just like guess and check, but the box method would have taken you to the same answer. Truna, would you agree?
Yeah, I actually did the box method. So it's just really preference. It's fortunately one of those things in math where you can actually try some different things and get to the same result. Sometimes we have to be a little more particular, but we've got some choice here.
So you can use can you use diamond guess and check or the box method?
Oh, okay. By box method, are you
No.
thinking like the multiplying? Maybe I'm misunderstanding. I think box is different, right?
Oh yeah. Yeah, we're not multiplying anything together, we're pulling it apart. So it's the diamond.
Oh,
Yeah.
Yeah, so
Thank you.
diamond, we should say, not box.
Yeah.
Okay, so let's do B, and I'm gonna do B, reviewing the calculator stuff, which I know it took us a long time on the last one, but I'll show you how it's gonna be a lot faster. So what I want you to do is we're gonna enter in this function into y1. So you're gonna go in your calculator and in y1, enter in x cubed minus 4x squared minus 5x. Okay, so I want you to enter in that polynomial into your y1. Okay, I'm gonna write it down. So x cubed minus 4x squared minus 5x. So y1, hit clear. X cubed. If you're like me, I always forget to arrow out of the exponent, so I always have to arrow forwards, otherwise everything ends up there, and it is really frustrating. So I have that entered in. Okay, then you want to go to your main screen. This is where you hit your blue button and load just to get back to your like home screen. I like to clear everything, so I start with a clean screen, so I hit clear. Who remembers where we go to get the y1? What buttons do we push to pull up y1? There are 2 buttons we have to hit. I'm going to pick on Brooklyn. Do you have the TI, do you have the 84 calc on your phone or graphing calculator?
Yeah, I do.
Okay, do you remember what button we hit to get the y1?
You press trace.
Good, it's right above trace, and because it's in green, we want to get to the F4.
You press
Alpha.
alpha.
So
Alpha.
good, exactly. Alpha, good. So alpha and then trace.
Yeah.
And then we hit enter, and then all you have to do is plug the number in parentheses. I guess I forgot to identify what number. So let's go back and look and see what number we're plugging in. On this first one, what x value makes this equal to 0? So x minus 1, what number makes that 0? X equals what?
A 1.
1, perfect. So our rule is we change the sign. So on our calculator, we want to plug 1 into this function. So I just do a parenthesis, which is right above the 8. I type in a 1, and we hit enter. We didn't get 0, which means it's not a factor. So then on our paper, I'm just going to write, this was -8. I write it does not equal, which is just an equal sign with a line through it. It does not equal 0, so it's not a factor. So I'm not going to use that one. Then I go to the next one. What x value makes that factor equal 0?
-1.
-1, perfect. So then on our calculator, we're going to plug in -1. So I go back here, we do alpha trace, select y1, and this time we put a -1 in the parentheses. And we kind of celebrate, or at least I do, whenever I get a 0, because that means that this is a factor. So on my paper, I can say this equals 0, so x plus 1 is a factor. Okay, so that's the first thing we need to do. So this is the one we want to work with. So now we do synthetic division. So the 0 is what goes in the box. So I put a -1 in the box. Okay, then I'm going to look at the coefficients that I have to list. Maddie, what coefficients do you think I'm going to have to list to set up synthetic division from here? What's the first coefficient I'll list?
I think it's 1,
Good, and then what?
-4, and -5.
Perfect. Okay, I'm going to do one quick check. This degree was a degree 3. So how many terms should I have written out if it's a degree 3?
3.
It's actually always one more, because what we're missing is we don't have a constant. It's like there's a +0. There is no constant at the end. There's always one more number that you need to have listed than the degree. So a degree 3, I would need one more number. So I actually have to put a 0 at the end because there is no constant. Okay, so the number of terms, I have 1, 2, 3, 4. I need 4 numbers listed because it's a degree 3. You always have to have one more. If you're missing one, you'd have it be a 0. Okay, then we drop the 1, and I'm going to go through synthetic division again. So synthetic division, I multiply these two. -1 times 1, that gives us a -1. And then we add -4 plus a -1 gives us a -5. And I repeat this process. So now the number in the box multiplies the number below, and -1 times a -5, that gives us a +5. And then we add, if we add these two, we get a 0. In this case, you'll notice I'm going to keep going because I have a number, but we could have stopped. -1 times 0 is 0. And sure enough, what we expected our remainder to be 0 because we got a 0 over here. And that's technically called the remainder theorem, but I don't care what we call it as long as we feel good that we've got that. Okay, so now we're ready to kind of write our final answer. This factor, or that 0 of x minus 1 or -1, came from x plus 1. That's the one that we started with, right? So we have x plus 1 in front. It was an x cubed, so x cubed drops down to x squared. So that means when I write this 1, that's 1x squared, then a -5x. You could say it's plus 0, but we're usually lazy. If it's a 0, I'm not going to write plus 0. I'm just going to leave it like this. And now our goal is to factor if we can. So I'm looking at this term here. Is it possible for us to factor that? There's only 2 terms. When there are 2 terms, I would not do guess and check, and I would not do diamond. I would be looking for a greatest common factor. Is there something that both x squared and 5x have in common? I'm going to pick on Zoe. Do you recognize, is there a factor that x squared and x both have in common where we could factor it out in front, where we could just pull it out in front? What do they both have?
Sorry, can you just repeat the question?
Yeah, and it's been a while, I know. So it's kind of the one where we're saying, is there something that I can divide both of these by that they both have?
Okay, so you can divide the x squared by x, and then you just get a regular x.
Great.
And then
and we can do the same with the other one, right?
Yeah. And then -5, just a -5.
Perfect. So again, I know it's been a while since we've done factoring, so you think of this today as an opportunity to practice. So they both had an x, so we could factor that x out in front. We typically leave the x in front of everything. So what I'm going to do, I have the x plus 1. That x I'm going to write in the very front. So this is my answer. So now it's in factored form. Not too bad? Okay.
Nope.
I want us to look at our assignment now. So you guys can pull it up on Canvas, or you can just follow along with me and then look at it later. There's only 4 questions that are like what we just did, and then there's a review of graphing on the back. So graphing, you guys are good at. You guys did great on your quiz. I want you to practice those. So those you'll practice on your own. Let's do one of these together. Okay, so let's look at number 1. The first question you ask yourself once you're given your factor is the 0. So let's see. I'm going to go with Natalie. What x value makes x minus 1 equal 0? What x value do I call the 0?
Will it be +1?
Perfect. Yep, a +1, exactly. So before I would try synthetic division, I want to know if I get a remainder of 0. So this is where you evaluate the function at 1. So we're going to plug 1 in for x. You can do it by hand, or if you're like me, I'm just going to do it on my calculator. So I want to enter in this function in on the calculator. Is this the same question we had in our notes? I'm now having a thought that looks exactly the same.
Yeah, I think it is.
It is. Okay, well then, good news for you guys. Let's just skip this one. So I'll let you guys skip this one because it's exactly the same as our notes. let's go to this one. So let's do number 2. What is the 0 on this one? On this first factor, x equals what? I'm going to pick on Maddie. What's the 0 of x minus 1?
+1.
+1, perfect. So step 1 is you evaluate to see if it is a factor. So you plug 1 into the function. If you want to do it by hand, it's just plugging 1 in, and maybe 1 would be faster by hand because it's a nice number. We're just plugging 1 in for x. So this would be 1 plus 3 minus 4 minus 12. Those two give me a 4. That's a negative 16. Well, that's a negative 12. That clearly is not equal to 0. Or on your calculator, you could have done y1 at 1. But once you get that it's not equal to 0, you say, okay, it's not a factor. I like to cross it out, so I know that one doesn't work. So let's try the next one. Zoe, what is the 0 of x plus 3?
-3.
Perfect. So step 1 is we're going to evaluate the function at -3. This one I do not want to do by hand. I don't want to plug this in. So I'm going to evaluate the function at -3. So I'm going to go into the y equals and enter in this function. So if you're like me, I'd have to write this equation down before I go to my calculator. So x cubed plus 3x squared minus 4x minus 12. So go into your y equals. We'll enter in x cubed plus 3x squared minus 4x and a minus 12. I hit second quit to go to my main screen, and then it's alpha or your green button and trace. We wanted to plug in -3. We are wondering if we get a 0 out. When we celebrate, we get a 0. This is good. A 0 means that it is a factor. So we get to say we got 0, so x plus 3 is a factor. And now we do synthetic division. Your 0 goes in the box. So the -3 is the number that goes in the box. I start listing the coefficients. I'm listing all of these coefficients. So I have a 1 from the x cubed. I have the 3 from the x squared, the -4, and the -12. I like to do the check, that is, if this is a degree 3, I should have one more term listed. So 3 plus 1 is 4. So notice I have 1, 2, 3, 4. So I'm good. I don't have to include any zeros. Okay, take a second, do synthetic division on your own, and then let's compare our answers. So see if you can do synthetic division to get the numbers below here. I'll write it, but I'll be quiet so you guys can think. I'm always thrilled when I get this 0 at the end, because that means I did it right. If I expected it to be a 0. Carson, were you able to get to here? Do you agree with my numbers on synthetic division?
Yeah.
Okay.
Just a little
let me-
confusing.
Yeah, it is. And I know it's because there's so many steps and there's so many things to think about. So at this point, we take this 0 came from a factor, but we already know that factor that -3 came from x plus 3. So my first factor is x plus 3. Okay, remember with synthetic division, we always drop by a power. So since our original one was an x cubed, when we do synthetic division, we drop. So now it's x squared, meaning this 1, the one here gets an x squared after it. This is x squared. Technically, there's a 0x and then a -4. I don't like to write the 0x, so I'm just going to say it's x squared minus 4. How do we factor x squared minus 4? Maybe remember, it's one of our special patterns. It's 2 terms, but the middle one is a 0, so maybe I should have left the 0. Let me leave the 0. I think it might actually make it easier. I'm still doing guess and check because I can think about it as 3 terms. I know x times x gives us this. Do you know, Carson, what are the other 2 terms going to be?
Is it 4 and 4? Or
Okay,
2
so
and 2?
2 and 2, good, because you need 2 numbers that multiply to 4. Well, 2 times 2 multiplies to 4, so that works. To get the 0 in the middle, we just do 1 plus and 1 minus. This is called the difference of squares pattern, because x squared is a perfect square and 4 is a perfect square. So it's x plus a number and x minus that same number. And now we're done. So a degree 3 should have 3 separate factors. And we've got them.
Whoever made this math should be banned.
No, I promise. Right now it seems like it's a lot of work, but once everything comes together, you're going to see how this ties back into what we were doing here. And so pretty soon you're going to be like, oh, there's a purpose for it. So I like it because now it's at least giving us a reason, like why would we ever do synthetic division? Synthetic division helps us factor. So this is, I'm going to make you appreciate it in time. I know today you
Too
may
many
not appreciate
numbers.
it. Yes. So today is hard
Hey,
to
Ms.
appreciate.
Brown?
In a couple days. Yeah.
Are we just not supposed to do number 1, or did we just not?
Yeah.
Do
I'm
it
okay
for-
if you just skip it because it's the exact same problem from your notes. So you can just
That's
start
fair.
on number 2.
No.
Yeah.
Thank you.
Yeah.
2 to go. That's all.
Yes. You only have 2 more to go. So 2 to go. And then the backside should be pretty fast because that's a review. Try this one. Go ahead and take a second and try this. I'm gonna pick on people to go through this. Or Eileen, do you want to walk them through this one? Or Struna, sorry, do you want to walk them through this one?
Oh yeah, it doesn't matter. I'm not worried about my name either, Brown, but yeah.
Okay. I forget.
Yeah, let me I think I'm set up, so let me see if I can.
Okay. So while she's doing that, guys, you guys go ahead and start this one, and then she'll take you through it. But see what steps you remember and how to go about doing these. And I'll stop presenting.
All right, and I think, is it showing up?
Yep, it looks like it's coming in.
Okay.
Perfect.
All right. Let's see who I can see here on my list. I'll just work I'll start from the bottom here. Zoe, what did you find that were your zeros?
X equals -1 and x equals +4.
Excellent. And then Zoe, before you get off, what's our next step now that we have those?
You plug those numbers into the x's. So for f of -1 equals -1 cubed plus do you want me to like say
You're
the whole
okay.
problem or
No, that was good. You're gonna plug it in. I'm gonna do it by the calculator. So
Okay.
you have the right idea. You're gonna make sure you put it in